Light energy. Light. Physics is that branch of physical science which deals with matter and energy. We cannot see or touch light. It does not have any weight or cannot occupy any space. But we can perceive light. The world is so beautiful, and this is because of presence of light. It makes everything surrounding us visible. So, we can conclude that light is a form of energy. From the viewpoint of physics, we can say that light is one form of electromagnetic wave that causes the sensation of vision in our brain. Activity. Reflection of light. Take a beaker of glass half filled with clean water. Take a small wooden pencil. Put it inside water and look at it from outside. You will see that pencil appears to be broken, but actually it is not. This is due to the refraction of light. Light can travel through vacuum and in any other transparent medium. While traveling through a medium, light always travels in a straight line. This property of light is called rectilinear propagation of light. But when it travels from one optical medium to another and is incident at the surface of separation, it deviates from its original path. We call this property of light as refraction. But before coming to refraction, let us talk about the optical medium. Optical medium is a technical term by which we mean a transparent medium like air, water, glass, etc., through which light can easily pass. But simultaneously, it is also to be remembered that light does not travel with the same speed in different media. In vacuum or in air, light travels with a speed of 3 × 10⁸ meter per second. This is the maximum speed with which the light moves. But however, in any other medium like glass, the speed of light slows down. Optically rarer and optically denser medium. The medium in which light travels with a greater speed, we will say that the medium is optically less dense or rarer medium, while the medium in which the light travels with a lower speed, we will say that it is optically denser or simply denser medium. For example, the speed of light in glass is 2 × 10⁸ millisecond raised to the power -1, approximately, while in water it is 2.25 × 10⁸ millisecond raised to the power -1, approximately. Thus, we can say that glass is optically denser than water. Scientist. Gustav Kirchhoff, a German physicist, 1824 to 1887, studied light spectra using spectrometer he developed with the chemist Robert Bunsen. He observed that individual atoms and molecules emit certain colors only when heated. Kirchhoff realized that each element produces a distinct spectrum of colored lines that can be used to identify the element. Refraction. When a ray of light traveling from one transparent medium to another strikes the surface of separation between the two media, a part of light is reflected back to the same medium while the remaining part travels through the second medium. But in the second medium, light does not follow the same path. This change in direction of light is referred to as refraction. Refraction of light. When a ray of light passes from one transparent medium to another with different optical density, it deviates from its original path. This phenomenon is called refraction of light. Activity. To understand the phenomenon of refraction of light, place a large shallow bowl on a table and put a coin in it. Move away slowly from the bowl Stop when the coin just disappears from your light. Ask a friend to pour water into the bowl. Keep looking for the coin from your position. Observation. The coin becomes visible again. It appears slightly raised above its actual position due to refraction of light. Rules regarding refraction. In the figure A, we see that AB is the interface which separates two mediums, air, rarer, and water, denser. A ray of light, XQ, makes angle XQM with the normal. It goes in the other medium along the path QY, making angle YQN. MN is called normal. The ray of light is not following the straight path XQR, but it bends towards the normal. Angle YQN is smaller than angle XQM. In the figure B, XQ is the incident ray striking the interface AB, separating the two mediums, water, denser, and air, rarer. The ray QY is the refracted ray which bends away from normal. It shows that angle of refraction YQM is greater than angle of incidence XQN. Hence, whenever a ray of light travels from denser medium to rarer medium, it goes away from the normal in rarer medium. Thus, we can summarize the phenomenon of refraction as: when a ray of light passes from one optical medium to another, there may be three possible situations. 1. When a ray of light passes from rarer medium to denser medium, it bends towards the normal and angle of refraction is smaller than the angle of incidence. That is, angle R is less than angle I. 2. When a ray of light strikes at right angle to the interface of the two mediums, it does not deviate from its original path and goes straight. In this case, angle of incidence and angle of refraction both are 0. 3. When a ray of light passes from denser medium to rarer medium, it bends away from the normal. In this case, the angle of refraction is greater than the angle of incidence. That is, angle R is greater than angle I. Fact: when light bends, it tricks us into seeing things in the wrong place. A mirage is caused by light refraction in the atmosphere. Now, think about the conditions under which the refraction of a light ray does not take place though it passes from one optical medium to other. The conditions are as follows. 1. If the angle of incidence is 0 degree at the boundary of the two media. 2. If the optical densities of both the media are the same. Examples of refraction. 1. A stick placed obliquely in water appears to be bent and short. This happens due to refraction. Let us consider a stick APO. The rays of light coming from the APO of the stick suffer refraction at the surface of water and bend away from the normal. Our eyes cannot follow this bent path at light. So, the light rays appear to come from the virtual image O'. So, the stick appears to be bent and short. 2. A clear pool of water always appears to be shallower than it actually is. 3. A coin placed at the bottom of beaker containing water seems to be raised. 4. The sun appears flattened at the time of sunset and sunrise. 5. The stars seem twinkling at night. Curved mirrors. Mirrors with curved reflecting surface are called curved mirrors. Curved mirrors are of two types. 1. Concave mirror. 2. Convex mirror. Concave mirror. When the reflection of light occurs from the hollow inner side of the curved mirror, it is called a concave mirror. Convex mirror. When the reflection takes place from the outer bulging surface of a curved mirror, it is called a convex mirror.
Uses of curved mirrors. Uses of concave mirrors. 1. They are used as reflectors in headlights of automobiles, in searchlights, torches, etc. 2. They are used in reflector-type solar cookers to convert sun rays in order to generate adequate heat. 3. They are used in large-size telescope. 4. They are used as shaving mirrors. When the face is kept between the pole and the focus of the mirror, an enlarged image is formed. 5. Doctors use concave mirrors to focus light to see inside organs like ear, nose, teeth, etc. Uses of convex mirrors. 1. They are used as rear-view mirrors in cars, buses, etc. 2. They are used to diverge light in streetlights. 3. They are used as vigilance mirrors in departmental stores and big shops. 4. They are used in staircase of double-decker buses. We can list the differences between concave and convex mirrors as given below. Concave mirror. Convex mirror. 1. It is made by silvering the outer surface of the hollow sphere. 1. It is made by silvering the inner surface. 2. Reflection takes place at the inner surface. 2. Reflection takes place at the outer surface. 3. It converges the light rays incident on it after reflection. 3. It diverges the light rays incident on it after reflection. 4. Image formed is real as well as virtual. 4. Image formed is always virtual.
Terms related to curved mirrors. Pole. Geometrical center of the spherical mirror is called its pole, denoted by P. Aperture. The largest line joining the extreme ends of a spherical mirror through which reflection takes place is called aperture. It is denoted by M1, M2. Focus. When the rays of light parallel to the principal axis strikes a spherical mirror, and after reflection they either meet or appear to diverge from a point, the point is called focus of the spherical mirror. It is denoted by F. In a concave mirror, the parallel incident rays after reflection converge, that is, meet at focus. In a convex mirror, the parallel incident rays diverge, that is, scatter after reflection. On producing them backward, they appear to meet at focus. Distance between focus and pole is called focal length. It is denoted by F. If F is the focal length and R is the radius of curvature, then F is equal to 1 by 2 into R, or R is equal to 2F. This relation is true for concave mirror as well as convex mirror. Center of curvature. The center of the hollow sphere of which the spherical mirror is a part is called center of curvature. It is shown by the point C. Radius of curvature. The radius of the hollow sphere of which the spherical mirror is a part is called radius of curvature. In the diagram, it is shown by PC. The radius of curvature is generally denoted by R. Principal axis. The imaginary line which joins the pole and the center of curvature is called principal axis. In the diagram, PX is the principal axis. Rules for making ray diagrams of spherical mirrors. For construction of a ray diagram, we must take two rays whose path can be traced after reflection. To locate the position of the image formed by a spherical mirror, we should know certain rules for our convenience. 1. An incident ray parallel to the principal axis either passes through the focus in concave mirror or appears to come from the focus, convex mirror, after reflection. 2. A ray passing through focus is reflected parallel to principal axis. 3. An incident ray passing through the center of curvature is reflected back along the same path without any deviation.
4. An incident ray falling at the pole of the mirror is reflected back, making the angle with the principal axis equal to the angle of incidence.
Real and virtual images. The image which can be obtained on a screen is called a real image. It is formed when light rays after reflection actually intersect. The image which cannot be obtained on a screen is called a virtual image. It is formed when light rays after reflection do not intersect or appear to diverge. When they are produced at the back, they intersect. It is shown in figure. Difference between real and virtual images. Real image, virtual image. 1. These rays after reflection actually meet at a point. 1. These rays after reflection appear to meet at a point. 2. It is always inverted. 2. It is always erect. 3. It can be obtained on screen. 3. It cannot be obtained on screen. 4. The image is formed in front of the mirror. 4. The image is formed behind the mirror.
Ray diagrams with curved mirrors where real images are formed.
Images formed by a concave mirror. 1. When the object is at infinity, the image formed is A. Real and inverted, nature. B. Highly diminished, size. C. At focus in front of the mirror, position. 2. Object lies between infinity and center of curvature. The image formed is A. Real and inverted. B. Between C and F. C. Smaller than object. 3. Object at center of curvature. The image formed is A. At center of curvature C. B. Real and inverted. C. Same size as object. 4. The object lies between center of curvature and focus. The image formed is A. Beyond C. B. Real and inverted. C. Enlarged. 5. When the object is placed at focus, the image formed is A. At infinity. B. Real and inverted. C. Highly enlarged. 6. The object is situated between focus and pole of the concave mirror. The image forms behind the mirror. The image is enlarged, erect, and virtual. In this case, the two reflected rays do not actually intersect but appear to meet at a point behind the mirror. These are shown by dotted lines. Images formed by a convex mirror. 1. When the object is placed at infinity. The image formed is 1. Highly diminished. 2. Virtual and erect. 3. At focus behind the mirror. 2. When object is placed anywhere between pole and infinity. The image is formed between the focus and pole behind the mirror. The image is diminished, erect, and virtual. Check your progress. Find the focal length of a convex mirror whose radius of curvature is 30 centimeters. Dispersion of white light into constituent colors. Newton was the first to study about the behavior of white light when it is passed through a prism. He said that when white light is allowed to pass through a prism, it breaks into its constituent colors. This is called dispersion of light. This happens because Each color undergoes refraction in different ways. The speed of light in a medium is different for different colors. Thus, the refractive index of medium is different for different colors. Due to this, each color deviates differently. The group of colors is called spectrum. The prism does not emit any light. It splits the white light into its constituent colors. Activity: recombination of white light. Take two identical prisms and place one prism in a straight position. Allow a narrow beam of white light to pass through it. It splits into its constituent colors. Place another prism near the first one in such a way that its position is opposite to the first one. Allow the band of split light to pass through it. The colored band again joins and forms a white light. The first prism is called dispersing prism and second one is called recombining prism. The combination of two prisms works as rectangular. Dispersion: the splitting of white light into its 7 constituent colors while passing through a prism is called dispersion. Activity: dispersion of light. Take a prism and allow a narrow beam of light to fall on it. Place a white screen on the other side. You will notice that a band of colors appears on the screen. The band of colors resembles a white rainbow as shown in the figure. The order of colors from the base of the prism is violet, indigo, blue, green, yellow, orange, red. Spectrum: the color band obtained on the white screen as a result of dispersion of white light while passing through a prism is called spectrum. Some important facts about spectrum are as follows. 1. White light is a mixture of 7 colors: violet, indigo, blue, green, yellow, orange, red. Vibgyor. 2. During the passage through a prism, different colors deviate through different angles. The deviation is maximum for the violet and least for the red. 3. In glass, the speed of red light is maximum while violet moves with minimum speed. 4. Refractive index of a medium is different for different colors, least for red and greatest for violet. 5. The constituent colors of white light can be recombined. 6. Different colored light waves have different wavelengths. Red light has the largest wavelength and violet light has the least wavelength. Other colors have intermediate wavelengths. Rainbow. The rainbow is a wonderful example of dispersion of light. How does a rainbow occur? A rainbow is formed when raindrops of water in the atmosphere disperse the sunlight. This phenomenon occurs just after rainfall when there are a large number of tiny water drops in the atmosphere which act like tiny prisms. The beam of white light from the sun passes through these water drops and undergoes dispersion. The emerging light is split into its constituent colors and we get to see the rainbow. Conditions for the formation of a rainbow in the sky are: the sun and the rain must be opposite to each other. The sun must be low in the sky. The observer must have his back to the sun. Activity: to show that white sunlight is composed of 7 colors. What you need: a glass tumbler, water, white paper. Procedure: 1. Place a glass tumbler on a window in direct sunlight. 2. Fill the glass to the brim with water. 3. Find the rainbow that forms on the floor. Place a sheet of white paper where the rainbow falls. Identify the colors in your rainbow.